I'm taking 2 different samples from her center, regular tap water and filtered water, and bringing them to the lab for testing. I want to know if filtered water truly has higher levels of essential minerals like calcium and zinc, and lower levels of chlorine and fluoride, which some filters promise to remove from our tap water.
So you tested both tap and filtered water. What do the results tell you?
For chlorine, you can see that the concentration has actually remained the same. It is 0.1 milligram per liter. So there's no significant decrease in the concentration. But if we were to look at fluoride, we do see a decrease from 0.5 to 0.1. So the reverse osmosis filter did remove fluoride from the water itself. But the permissible level for fluoride in our water is actually 0.7 milligrams per liter.
Right.
So as long as you do not go above that, it is safe.
Some people believe that the filter will actually add more minerals into the water. Is that true?
If we were to look at the results between tap and filter, magnesium level only went up by 1 milligram per liter. And if you look at zinc, basically there's no change to the concentration. And for calcium, there's actually a decrease from 30 milligrams per liter to almost 1 milligram per liter. So if we were to add all 3 minerals up that we are observing in our report, it's actually a drop in overall mineral contents.
So in other words, this filter is actually removing more minerals from the water instead of adding minerals into the water.
You're correct.
So water filters may be able to remove fluoride from your water if that's what you're concerned about. But if you are looking at adding minerals into your water, well, filters may not necessarily live up to their claims. There are 2 common kinds of filters which claim to modify water: ion exchange filters and alkaline filters. Chenko is going to show me what really goes on in each of these filters.
So what's this one that we're looking at?
This one that you're looking at is an ion exchange filter. It acts like a water softener. Imagine your hard water going into the filter.
And what makes water hard?
Well, basically, if you have calcium and magnesium ions inside your water, it contributes to the hardness.
So hard water has more of this, the calcium and magnesium?
Yes, that's right.
Alright, how does it work?
Imagine this part here is your water filter, and the yellow magnetic ion exchange resins.
Okay.
Hard water goes in from the top, and this is calcium. It gets captured by the ion exchange resin, releasing some of the hydrogen ions into your outlet water. So eventually, most of your calcium and magnesium ions will be captured by the ion exchange resin, and out comes soft water. The lack of calcium and magnesium ions make the water soft.
Softer water is often desired by coffee enthusiasts because the lack of minerals can prevent limescale buildup from clogging your coffee machine. Some also believe that using softer water can brew a more flavorful cup of tea.
Now, over here we have what we call electrolysis. It's basically used to produce alkaline water. You need an electric current to go through your water and split it, and in the process it produces alkaline water. If you can see, one of these electrodes has a lot of bubbles coming out where alkaline water is produced. If I put this into my electrolyzer here, you can see a deeper green which indicates alkaline water according to the color chart.
Oh yeah, so it is converting the water in there by running a current through it.
Yes.
And alkaline water is also supposed to be beneficial for us?
Yes, a lot of people do believe it's more beneficial, it's healthier.
Next is the other kind of filter that is designed to remove contaminants from water, the activated carbon filter.
Activated carbon is a very common component in a lot of filters.
Chenko proceeds to pour some blue-dyed water through a coffee filter lined with activated carbon. That's the black powder you see there.
You can see the water dripping out now.
It's not as blue.
That's right.
So essentially this carbon is absorbing the blue dye.
Yes. And imagine the blue dye is your contaminant in the water. That is what your activated carbon is doing. It's removing certain pollutants. For example, solvent, chlorine, and certain chemicals. It can't remove bacteria unless it's specially designed to do so.
Okay. For people who are out there looking for a water filter, what should they be looking out for?
First point, they must already know what they want to remove from their water or modify their water. For example, are they going to remove chlorine and fluoride? If that is the case, they should look for a water filter that can handle that particular task. Second point, a water filter which is certified by a third party, not related to any of these manufacturers or retailers.
Okay.
My third point for consumers is to think about how often you need to change your filters.
Yeah.
Now, the problem is this. Filters over time can actually allow bacteria to grow within them. And of particular concern will be the activated carbon because it absorbs organic matter, which actually serves as food for bacteria. So we are talking about bacteria growing on your filter and coming out into your water which you are drinking.
Right, so if you don't change it regularly, it's like the clean water going in, getting mixed up with all the bacteria and then coming out into your cup.
Yes.
Which is even worse, right?
Yes, that's right.
So I've gathered water samples from 5 different households who use water filters, including my own. I've taken 2 samples each from these households, one of filtered water and one of regular tap water. I'm sending the samples to the lab for testing today. I want to know how effective water filters really are in our homes. It's been a week since I dropped off my water samples at the lab for testing. And the results are out. I've also invited the households I took the samples from. Turns out, the bacteria count for tap water taken from 4 of the households were all under 500. Some as low as less than 1. A bacteria count of 500 is the safe limit imposed for Food Agency. But when it came to filtered water from these 4 households, 3 of them had bacteria counts that were between 9,000 to a whopping 25,400.
My number is about 25,000, which is like a lot more.
Yeah, that sounds pretty high.
Was your filter changed recently, or so you have used it longer than what the manufacturers recommends, right? Okay, that could explain the high bacterial count. So the longer you keep your filter running, the higher probability that you will have a regrowth of bacteria. So it's very important to follow the schedule proposed by the manufacturers.
But even then, so I actually did just change my filter about a month ago. I would have thought there should be, well, almost no bacteria since it's almost a brand new filter, right?
So bacteria regrow very fast. So as soon you have nutrients and surface to regrow, you will have development of a biofilm. So if you look at it this way, having a filter, add one more step after the water you receive from the tap. And in that particular filter, there is an additional, basically, opportunity for the bacteria to regrow.
So are water filters really necessary? Well, if you think about how rigorous our water treatment process is, the answer is no. Our tap water is perfectly safe to drink.